number 18B, referring to the recharge of aquifers in urban environments. We have the lack of having representation of different countries and very varied issues. We're going to start with Mr. Andrés Benton from the Asociación Hidrológica Mexicana from Mexico, which is going to tell us the deal of the recharge of the aquifer in Mexico City through infiltration wells. I'm going to ask you to make it in 25 minutes. Okay, thank you for your time. Thank you very much.
Yeah, good afternoon. I will talk about the program of recharge of aquifers through wells in urban areas. Because of the setting of the Aztecs capital in and around the lake, always everybody was worried about the floods of the city that were very terrible during 400 years. This followed in the last centuries, and all the people were thinking about the draining the lake, that the lake covers half of the Valley of Mexico. So finally, were made projects and works to reach this goal. And the big lakes in the valley almost disappeared. Now, there are remaining only a few, like the Nabor Carrillo Lake, that is a salad lake, Zumpango, Xochimilco, Chalco, Texcoco, and other little lakes. There you can see Nabor Carrillo, and Texcoco Lake, Xochimilco and Chalco, and all the urban city. Since 1950, the urban sprawl of the Valley of Mexico has been expanding, setting indiscriminately in agricultural areas that on those times supplied the food consumption for the inhabitants of the valley, and also had been areas provided of vegetation that favored the recharge of rainwater, and to the use of water for the agricultural irrigation recharge the aquifers. As a result of those actions, a double problem has been presented, and it is increasing seriously. On one hand, the dramatic decrease in natural recharge, and on the other, the gradual increased pumping of groundwater to supply the population since the last century. Due to serious problems of flooding areas during the rainy season, the rainwater drains into the collector systems, degrading its quality and leaving the Valley of Mexico, thus losing the most important source of recharge of the Valley aquifer. The recharge program that are carried out by the city government to partially reverse this serious situation turn out to be very beneficial to some aquifers that supply part of the population of the Valley of Mexico in the south of the Federal District. This area are covered by a formation called Chichinautzin, that is a quaternary volcanic formation with rocks like basalts, pyroclastics, boulders, ashes, and sands, and all of these materials present a very high permeability. The rainwater that runs along the streets in the urban area now to the bottom of the valley, in addition to not infiltrating the water, causes water flows which hinder vehicular circulation. Through the wells program, this problem was minimized, and on the other hand, the recharge benefits the existing aquifers. During 2004, the water system of Mexico City carried out a construction program of 52 subsurface recharge wells, and catchment structures, with a project capacity to infiltrate the aquifer up to a total of 4,500 liters per second, between 50 and 150 liters per second per well of rainwater that drains into the rock formation to the aquifers. The proven capacity of the recharge wells finally results in 6,000 liters per second, of course depending on the rainwater. That in this part of the valley is around 1,200 millimeters. That is very good. Here we have a map with recharging wells and some cross sections that we make for making a map of the formations. It is important to consider that until now, there is no precedent in Mexico of a great vision program of wells with capacity to recharge more than 4.5 cubic meters per second to an aquifer, with some wells that can be recharged up to 150 liters per second, like it was made by the Water System of Mexico City program. During these works, we established a technical control that allow obtain detailed information of the hydrology in the recharge area using pump tests, well, in this case, recharge tests. Here we have a view of the structures. The grids on the street are in the left side, then the conduction, and the structure for solids and oil separation zone, and the recharge well. Here was one example of well. It drills basalt and pyroclastics, then basalts, and then basalt and pyroclastics that are very permeable. Once the site was located, exploratory drilling work was carried out at the depth of the project, which varied between only 10 to 15 meters, depending on the drilled formation. During this exploration, samples of cuttings were taken for the classification, as well as data of low circulation and depth where rocks and sands were fallen. All these data related to the very high permeability of those geological formations. It is convenient to clarify that these wells were drilled in the unsaturated area and with an elevation above the episymmetrical level, as it is considered in the existing normative in Mexico. Once the exploration was completed, recharge tests were carried out by the controlled discharge of water, with volumes to reach flow rates between 80 to 170 liters per second. To define the permeable zones and values of each well, the abatement and recovery data were used applying the Jacobs approach formula, and with this data it was possible to establish the correlation with the geological strata of the well. Here we have the recharge test. In red is the flow injected, and in blue is the behavior of the recharge. With the data of the recovery, we make this graphic, and in this case, we found a permeability of 44 meters by day. That is relatively good. Here it was the part, the thickness is in yellow, and it's the classification and the permeability at the left side. Here we have another graphic. In this case, 170 2 liters per second were injected to the well, and we have the comportment of the curve in blue. In this case, we find 2 aquifers, one in the upper part of the well that has a permeability of 6,000 meters per day, and in the down part of the well, it has very little permeability, but it works very well. This well has the capacity to recharge around 160 liters per second. Here we have the geological section, one geological section, and making all the sections, we make the geological 3D model. As you see, it is in the mountain. And here we have the geologic sections with the permeable zone in yellow and in green, very permeable zone, very permeable, and not permeable in red. Here we have a cutting of this well. And the recharge program was very successful because it has been located in a favorable geological formation with very high permeability and because of the extensive area covered with the well. These works were relatively low cost because the depth of the wells were almost superficial, between 10 and 15 meters deep, having also solved serious problems of water clogging of the drainage and flooding in the streets that impaired the good circulation of vehicular traffic. We recommend to support these good recharge programs. We need to consider that the success is based in the high permeability of the geological formation recharge. It is essential periodically establish the maintenance of the structures and wells, preferably before the rainy season. Thank you very much.
Andrés, is there any questions for Andrés? Are there any questions? There are no questions? Yes? The microphone.
Thank you for an interesting presentation and overview. Fully agree with your recommendations. How has the infiltration capacity of these wells developed over time? Have there been any signs or problems with clogging? Did you need to clean these wells frequently? Can you comment, please?
Well, we make the recharge test, so interpreting the curve that you obtain, you can see where are how much is the thickness, permeable thickness, and we obtain the permeability. That in this case, in this zone, is incredible. The permeability is secondary permeability because basalt has many solid strata. And in this place, there is a top that has been covered with the basalts, and the top is used like the base where the water arrives and goes to the valley to recharge the aquifers in the valley. And the result was incredible. For 6,000 cubic liters per second, only during the rainy season, but that will represent around 100 liters per second that you are 1,000 liters per second at least that goes to the aquifer. And we are
Thank you.
recommending that they make 2 or 3 times the number of wells and structures to use to have a more recharge cost.
Thank you.
Any other question? No? I have one question for you. You have shown us 52 wells all around Mexico, but all of them were in urban areas, no? Does the traffic pollutants or the pollution of traffic affect to the water quality?
Well, they were made as the laws said, around 60 meters over the static level of the aquifers. And it has a trough that it maybe cleans. The trough is permeable. So we hope that it doesn't have problems. And the government takes tests of the wells that are around using for the population, and they have not find any problem until now. You have to consider that. It's a thing that you have to be looking, not have a problem of contaminating that.
Okay, thank you very much.
Thank you.
Thank you.